Now to understand clearly the projectile motion, we have to solve the numericals based on the projectile motion. Let's take the first numerical. Question number 1. A grasshopper a grasshopper a grasshopper can jump can jump can jump up to a height h up to a height small h. Find the maximum distance. Find the maximum distance. Find the maximum distance through which it can jump. Through which it can jump. It can jump along the horizontal ground. Along the horizontal ground. Now copy this numerical first, then you solve it. What is given? A grasshopper can jump up to a height h. Up to a height h means there's a maximum height. It can jump vertically. So here we have to consider theta equals to 90 degree. Now the formula of the height h equals to u square sine square theta by 2g, and putting theta 90 degree, that formula reduces to h equals to u square by 2g. That is the maximum height the grasshopper can jump. From that we have u square equals to 2gh and u is equals to under root 2gh. Now here we have to find the range. There's a maximum range. Find the maximum distance. What it's mean? We have to find the maximum range. And for the maximum range, we know the formula u square by g sine of 2 theta. Theta is for maximum sine 91. So putting u square equals to 2gh here, 2gh by g. So g will be cancelled out and we have 2h. That is maximum range r is equals to 2h. Maximum range is r is equals to 2h. Okay, student. Now move to the next numerical. Write the numerical. A projectile can have same range. A projectile can have same range. A projectile can have same range or capsar. There's a capsar for two angle of projection. For two angle of projection. If T1 and T2, if T1 and T2 are the times of flight, in the two cases, the two cases, in the two cases, then what is the product? Then what is the product? What is the product of two time of flight? Of two time of flight. First copy this numerical, then we will discuss it. First copy this numerical, then we will discuss it. Then we will discuss it. Here, two time of flight is T1 and T2, and the range is given R. For both the projectile, range is same. Here is the concept hidden. If the range is same, then there should be the angle of projection. One is theta, another is 90 degree minus theta. That is, the angle is complementary. Angles are complementary. So we have T1, that is the time of flight, T1 is equals to 2u sine theta by g. Another should be T2 is equals to 2u sine of 90 degree minus theta by g. Angles are complementary. Now sine of 90 degree minus theta means cos theta, that is equals to 2u cos theta by g. Now let's multiply both T1 and T2, because here the question demands, then what is the product of two times of flight? Now let's multiply T1 and T2. That T1 into T2, that is equals to, we have 4u square by g into sine theta cos theta. Now breaking 2u square by g 2 sine theta into cos theta, that gives us 2, that is the formula of the range, that is 2r. So we have T1 into T2 is proportional to R. From that concept, what we have understood, that if the two projectiles are thrown with the angle complementary to each other, that is, they have the same range, the product of the time of flight should be proportional to the range of the projectile. That is the concept hidden here. Now let's move to the third problem. Let's move to the third problem. A ball is thrown. A ball is thrown. A ball is thrown at different angles. At different angles. At different angles with the same speed u. With the same speed u. With the same speed u. And from the same point. And from the same point. From the same point. And it has the same range in both the cases. And it has the same range for both the cases. For both the cases. For both the cases. If y1 and y2 are the heights attained, if y1 and y2 are the heights attained in the two cases, cases find y1 plus y2. Now this numerical reflects the same concept of the previous one. Here the range is same and the velocity of projection is u, and the heights differ from each other, that is y1 and y2, and the angles are complementary to each other. If we draw this, what we'll get? Two-dimensional motion. This is x, this is y. For the first case, this is y1, and for the second case, that is y2. Now here y1 is equals to u square sine square theta by, we write the 2g, that is the formula of the maximum height. Now the another one, what we'll write? y2 is equals to u square sine square 90 degree minus theta by 2g. So sine of 90 minus theta is cos theta. So we have u square cos square theta by 2g. Now adding y1 and y2, as per the question, we have y1 plus y2 is equals to u square g by 2g is common. We have sine square theta plus cos square theta. So we get u square by 2g. U square by 2g. What the concept we have gathered from that numerical? Because if the velocity of projection is same, angles are complementary to each other, that is the range is same, then the addition of the maximum height for both the cases is equals to the maximum height for the vertical motion of the object. That is y1 plus y2 equals to u square by 2g. Okay. Now let's move to the another question. Another question. The equation of motion, the equation of motion of a projectile is y equals to 12x minus 3 by 4 x square. 3 by 4 x square. The horizontal component of velocity is 3 meter per second. And what is the range of the projectile? What is the range of the projectile? What is the range of the projectile? Now, it's a tricky question. We know that the equation of motion of the projectile is y equals to 12x minus 3 by 4 x square. Now for the range, the object starting from here and comes to the earth again. That is, for the range R, we have y equals to 0. Y equals to 0. So 0 equals to 12 R minus 3 by 4 x square. That is R square. R square. From here we have 3 by 4 R square is equals to 12 R. 1 R cancel out. Then we have 3 4 12 and R is equals to 4 4 16. Thus the range is 16. Range is 16. That's all for the day. We will solve many numericals in the next class. For the day, it's completed our lesson.